Okay. This will be the last drawing. We'll do the horse. We'll do non-structural carbohydrates first. I don't know why I spelled it out, but whatever. So we'll draw the line through the horse, just like normal. And in the mouth, we'll have our customary reduction in particle size. We'll then have the horse, not much is going to happen in the mouth, the esophagus or stomach, reach the small intestine. Pancreas is going to secrete pancreatic alpha amylase. And it's also going to secrete buffer, which is going to raise the pH, and sodium to provide the sodium for the absorption of glucose. We're also going to have the brushy border enzymes, which you can get from the pig drawing. And then we'll have them, the horse will be releasing, the small intestine will be releasing glucose, galactose if it's nursing, and fructose. Those three will be absorbed. We'll draw an enterocyte. We'll use SGLT1 to absorb glucose and galactose, and we'll use GLUT5 to absorb fructose. On the basolateral membrane, we'll have GLUT2, which will facilitate the transport of all three to the liver. And then we'll move to the large intestine, and we will say more starch than the pig. Okay, because they're not as effective at digesting starch in the small intestine, more is going to show up. We'll have the production of acetate, propionate, and butyrate using the microbial enzymes discussed. We'll also have the production of CO2, CH4, and MCP, all of which get excreted. And then this acetate, propionate, and butyrate will be absorbed. Put a star here to remember that butyrate pulls energy, source of epithelial cells in the large intestine or in the fermentation chamber, which would be large intestine in this case. And we'll leave that glucose and galactose there and talk about that in a second. Take these all the way to the liver and let them hang out for a second. We'll now feed our horse structural carbohydrates. Okay, and nothing happens in the stomach, nothing happens in the small intestine. It's only when we arrive at the large intestine that microbial enzymes are going to produce acetate, propionate, and butyrate. It's actually going to produce the sugars that will be fermented into acetate, propionate, and butyrate. We're also going to produce CO2, CH4, and methane, which will get excreted. The acetate, propionate, and butyrate will get absorbed and go to the liver. Okay, in the liver, we can release VFA metabolites from acetate and propionate, butyrate, and from butyrate from propionate we'll release glucose. Okay. Glucose is also going to be released from glucose and from galactose and from fructose, and then those will get combined together as glucose that goes to the body. This glucose will also go to the pancreas, and at the pancreas cause the release of insulin, and then insulin is going to go act on muscle and adipose to increase GLUT4, which allows for glucose absorption, decreasing blood glucose concentration. Okay. On the horse, we'll draw muscle cells just so you have different cells. Different way to look at it. So I have two muscles. One has GLUT4 inside, the other has it outside, allowing for glucose absorption. It's because this one have insulin. No insulin there, so these are muscle cells. This could be a horse that doesn't produce insulin, right? And then this would be a normal functioning horse with insulin. This glucose can be used for energy, fat synthesis, which is what the VFA metabolites can be used for as well. Energy, fat synthesis, energy and fat synthesis. I'm just trying to remember anything else that I would make sure to learn. I'd make sure that I knew the enzymes to digest starch, enzymes to digest cellulose, and where those happen. Okay, the last thing on the horse that we need to capture is they're going to have more structural carbohydrate than pig, just because the diets we feed them are different. So that should be good.